Now it's a musical pitch. So how is pitch analyzed or be understood? So what exactly is pitch in terms of frequency in music? So the answer is we know already one octave. When we listen to two tones that are octave apart, then we know that the frequency ratio is 2 to 1 or 1 to 2. So in this example, C to high C, I'm going to play this. Okay, so that is octave apart. Okay, so second example is perfect fifth. So it is like C to G on the piano note is C to G. You see the piano note there. So there is a frequency ratio is 2 to 1. 2 to 1 is actually, in other words, is 1 to 1.5. Okay, so this is what it sounds like. Next, perfect fourth is C to F. So that's the piano. The frequency ratio is 3 to 4, which corresponds to actually 1 to 1.333. Okay, so this is what the ratio sounds like. And then major third, which is C to E. That's the piano note, piano picture, and then the frequency ratio is 5 to 6. 5 to 6 corresponds to 1 to 1.2. And this sound. And then finally, minor third is C to E flat. The frequency ratio is 6 to 7, and which is 1 to 1.166666. Okay, so this is what it sounds like. So basically, in music, in songs, all the musical melody, musical intervals can be actually represented by musical the ratios like this. Okay, let's skip chroma here. Okay, look at this piano chart again. The next slide, frequency range of musical notes. So here, the lowest frequency here is on the piano note is called A0. Frequency is what? 27.5 hertz. And the highest note, the frequency of the highest note on the piano key is C8, which is 4186 hertz. So it is really fairly wide range from low to high, really, really wide. And above this range of 4100 or so, 4100 hertz or so, the musical melodies are hard to recognize. So we cannot call that music anymore. So all the music is actually, all the musical tones, the frequency of the musical tones are actually below this, between these two range. Okay. Again, these are actually, think about, these are really the fundamental frequency. So all the harmonics can be above this, yes, but the fundamental frequency should be within this range. Just for your information, A4 is right here in the middle of the piano. That is A4. The frequency is 440 hertz. That's kind of the standard, international standard, which can be actually modified, adjusted by individual professional musicians. But just standard is 440. All right. Now, let's study what happens when someone has hearing loss. Okay, so pitch perception with cochlear hearing loss. What is it? So in general, DLF and FM DLs in hearing impaired listeners are a lot higher or poorer than in normal hearing listeners. Why? Because due to hearing loss, their auditory filters are broadened. Okay, so they do not have as fine tuning frequency as normal hearing listeners. So due to broadened excitation pattern and reduced cues based on phase locking, both. So both place mechanism and temporal mechanism there is compromised. And how much poorer than normal hearing listeners? That's really complicated. So that's not simple to answer because it depends on a lot of things. It's not. You may think that their ability, their poor ability, may be correlated with the degree of hearing loss. So the less hearing loss, still better. The vice versa. But it's not necessarily so. Obviously, of course, obviously, if someone has really profound degree of loss, then obviously the DLF would be really poor, yes. But other than that, except for extreme cases, in general, it is difficult to establish correlation. Why? Because it has to do with all kinds of other things, their musical abilities or their other experience in audition and so on. So it's really complicated. So a lot of individual variability going on, but generally speaking, their pitch perception is reduced, poorer than normal hearing listeners. Okay. What about someone with dead region in the cochlea? So what if there is a dead region in the listener? Pitch sensation around the frequency of that region is erratic. Erratic meaning that you cannot really predict with some systematic way. Sometimes almost normal, other times very unclear. Unclear meaning that if you play something at a tone, they may say, yeah, I hear the tone, but they don't perceive the tone as clearly as we perceive. And obviously pitch discrimination is poor. Also temporal mechanism of pitch does not work very well either. But in general, this topic is kind of messy, and it's difficult to. There's not much done, and we can actually do a lot more than this. So this can be actually a good research topic. What about missing fundamental in hearing impaired listeners? So can the recovery happen? Can the recovery take place as well as normal hearing listeners? The answer is not likely. The reason is because of the resolvability, resolved, unresolved. If available components are not resolved by individual distinct auditory filters, then recovery of fundamental frequency will not happen as reliably, as solidly as resolved case. And hearing impaired listeners generally have broadened auditory filters, so there's a more likely that higher chance of the tones, individual tones being not resolved. Therefore, the recovery of missing fundamental is compromised or reduced. So finally, I'm not including here in this lecture, but study this part in your textbook 170 and 172, perceptual consequences of altered frequency discrimination in pitch perception. It's always, this is actually very application, and this gives you very good food for thought about the information we learned in this chapter, and how you apply in hearing loss. Okay, all right, this is it.